Hello and welcome to Advanced Mathematics 1, Unit 7, Part 2, Multiplying and Dividing Rational Expressions. So we're going to be multiplying and dividing fractions, basically. By the end of this lesson, you'll be able to do the following. Simplify rational expressions, multiply rational expressions, and divide rational expressions. So basically, we're doing this with letters. It basically involves the same process as with numbers. We're going to be canceling out common things from the top and the bottom of the fractions. So our main concepts. So if you multiply a times c over b times c, you can eliminate the c's and you get a over b. You multiply a over b times c over d, then you get a times c over b over d. If you divide a over b by c over d, it's the same as multiplying a over b times d over c, and you get AD over BC. So just like with regular dividing of fractions, you have to flip the second fraction and then multiply. Basically, you want to start by factoring both the numerator and the denominator so you can work on canceling things that are in common in the numerator and denominator. And then you also have to write all the excluded values, which are any numbers that make any denominator 0. We'll get into that when we do the examples. So let's just jump into our first example. In the first example, we're supposed to simplify this expression, so we're going to do so by factoring. Now you can write things off to the side, or you can go through the factors however you want to do it, but we need two things that multiply to 45 that subtract to 4. Those happen to be 9 and 5. My 9 needs to be positive, so x plus 9, and my 5 needs to be negative. So this is where being good at factoring comes in handy because it'll go a lot faster the better you are. All right, and then we're going to factor the denominator, x squared minus 7x plus 10. So we're looking for things that multiply to 10 that are both negative and add to negative 7. So those two would be 5 and 2. So it's going to be x minus 5 times x minus 2. And then we are going to cancel out the common terms. So we have the x minus 5s are going to cancel out of both the numerator and the denominator. And I'm left with x plus 9 over x minus 2. Now, one of the mistakes a lot of people make is they want to cancel out these x's. Remember, x plus 9 is a number. It's not x and then plus 9. It's the whole thing together. So whatever x is, let's call it 5, it would be 14 in that case. It's not x and then plus 9. So just very, very important that you understand that. So my last step is that I have to write the excluded values. That's going to be what makes these two expressions equal to 0. If you want, you can write them off to the side, set them equal to 0, and solve for x. Or you can just remember it's going to be like the opposite of what's here. Just like we kind of did the last time when we were looking for asymptotes. We're looking for what makes it 0. So what makes x minus 5 0 is x equals 5. So it can't equal 5. And then what makes x minus 2 0 is 2. So it also cannot equal 2. So you can just write them comma like that. And that's basically the final answer. I mean, it is the final answer, and that's all there is to it. All right. In my second example, we're multiplying two fractions together. Now, there are two ways to go about this. That is just multiply everything out and then cancel at the end. I like to cancel at least the numbers first, and I actually multiply the letters first, numerator and denominator, because it just makes the canceling a little bit less complicated. So I'm going to go ahead and divide the 6 into the 48. So 6 times 8 is 48. And then we'll just recopy that in the numerator here. And then we're going to combine our terms in the numerator. So x to the 5th times x to the squared x squared is 7, and then y to the third times y is y to the fourth. And we'll do the same with the bottom. So we just have an x to the third down at the bottom, and y to the fourth, and y squared makes y to the sixth. So I'm going to take 3 x's away from 7. That leaves x to the fourth. And I'm going to take these 4 y's from these 6, and that leaves y squared. So all I'm left with when I am done is the 8, the x to the fourth, and the y squared. And then I need to write everything that would make a denominator 0. So anything, so that'll make the denominator 0. So x cannot be 0 because 0 to the third power is 0. Also, y cannot be 0 because it's also in the denominator. So that is the final answer. All right, let's move on to example 3 is another multiplication problem, but we're going to have to do some factoring here. So I'm going to do most of the factoring here, but there might be some things I write off to the side just to show you what I'm doing. So in the numerator, in this first fraction, the common factor is a 4. So I'm going to pull out a 4, and I'm left with x plus 3. And then in the denominator, I need 2 things that multiply to 30 and add to 11. They're both going to be positive, so that's going to be 5 and 6. X plus 6. And then that's that first fraction all factored. In the second fraction, the common factor would be 4x. And then I'm left with an x plus 5. And then in the denominator, I've got an x in common. So if you want to pull it off to the side, I'm just going to do it up here. Whoops, x. I'm just going to rewrite that, sorry. X times x squared minus 4x minus 21. And then I would want to factor that. So I have the x on the outside of my factors, and I need things that multiply to 21 that subtract to 4, and the bigger one's going to be negative. So that would be 7 and 3. So the 7 is going to be negative, and the 3 is going to be positive. And now I'm going to cancel anything that's in common. So the x plus 3's are going to cancel. The x plus 5's are going to cancel. The x and the x can cancel. And that looks like everything. So we have, in the numerator, we have 4 times 4 is all that's left, which is 16. And in the denominator, you can leave it in factored form. So you have x plus 6 times x minus 7. So I'm going to go ahead and write my excluded values. It's going to be anything that makes this denominator 0. So what plus 5 is 0 is negative 5. So it can't be negative 5. What makes x plus 6 0 is negative 6. What makes x 0 is 0. What makes x minus 7 0 is 7. And what makes x plus 3 0 is negative 3. So it can't be any of those numbers. So that's a lot of numbers, right? It's 5, 6, 0, 7, 3. Negative 5, negative 6, 0, 7, negative 3, sorry. So yeah, lots and lots and lots of excluded values in that one. All right, moving on to example 4. We have division. So basically division is multiplication. We change it to a multiplication first. So the first fraction I'm just going to copy, And the second fraction, I'm going to turn upside down. All right, now I'm ready to start simplifying. There's nothing that can cancel with the numbers. So I have up top, I have 32 times 8, which is 256. And then we'll multiply our x's up top. So x times x to the fourth is x to the fifth. And then we have y. And down at the bottom, I have y to the eighth and y to the third. So that's y to the 11th when we combine them. Now we can cancel. So we can take this y out of the y to the 11th and we're left with y to the 10th. So my final answer is 256 x to the 5th over y to the 10th. Now I have to write the excluded values. It's going to be anything that made any denominator 0. So in the original fraction, the x was in the denominator and the y was in the denominator. And in the bottom fraction, we have y in the denominator, but they were both in the denominator at some point. So neither one can be 0. Oops. So neither one can be 0. So that's what I mean by it makes any denominator anywhere 0. As you have to deal with this division problem. All right, our final example is a division problem again. So again, this top fraction over here has a common x, so I'm just going to pull that out. That leaves me with x squared plus 2x, sorry, this is very sloppy, minus 15. So when I rewrite that, I have an x on the outside. And then I need two things that multiply to 15 that subtract to 2, and the bigger one is going to be positive. So that's going to be 5 and 3. So the 5 is positive. Oops, that's a 5. And x plus 3. Let me see if I can correct this 5 a little bit. There we go. There we go. That's a better 5. All right, now we can do the denominator. The common thing in the denominator is x. So I have x times x plus 5. Now when I do a division, I have to actually turn the second fraction upside down. So the problem would be this first fraction times this one upside down. I'm just going to write it in its upside down form over here. So I don't forget which one's on top. Again, it has an x to the third and a bunch of x's that can factor out of that top. That's now going to be the bottom, but so it's x squared minus, actually, I'll just write it down here. X times x squared makes more sense. Minus 6x plus 9. And now we're ready to factor that. So in the numerator, the common factor is x. And that leaves me with x minus 3. And in the denominator, we still have that x out front. And then we're going to factor this. So we're looking for things that multiply to 9, that add to 6. They're both going to be negative. So that's going to be 3 and 3. So I have x minus 3 times x minus 3. And even if you did it as you recognize it as a perfect square, you want to go ahead and write out both x minus 3's so you don't confuse yourself. So now I want to start canceling. So one of the x minus 3's can cancel there. The x can cancel there. That's x plus 3, so that doesn't count. No, that shouldn't be plus. My bad, that should have been minus. Let's try that again. I can't write apparently, so it's x minus 3. That wouldn't have worked otherwise. So I didn't, there we go. So the x minus 3's cancel, the x plus 5's cancel, these other x's cancel. So that means everything canceled. So what does that mean? That means this thing is 1, because when everything cancels, the answer is 1. Then I got to do my excluded values. It's going to be everything that was in the denominator plus what was in the original numerator. So in the original denominator, I meant. So I have x can't be 0 from the first fraction over here. Then what plus 5 is 0 is negative 5. Again, x can't be 0 there. X minus 3, so it can't be 3, because 3 minus 3 is 0. And then I look at the top, and that just has an x and an x minus 3, so that's already all taken care of. So those are my excluded values, and I am done. So that is all for today, and I will see you next time. Goodbye.